you. I was thinking of ideas. Yeah. This is real life. I'm really solving this, and sometimes I don't know what to do at the beginning, and that's normal. Sometimes you have to try different things before you get to the answer. You see, you think I'm very smart, but I'm not. I'm just like everybody else. Right.
Yeah, exactly.
Okay. Right, next one now. Electromotive force and internal resistance, if you write this down. Yes, I know, it's difficult.
The name is difficult.
Yes, it is.
What about the rest of it?
It's not too bad, actually. It's not too bad. Did you write this down?
If I have some problem, can I miss the class?
If it's a big problem, then yeah. If you have to miss it, you have to miss it. You have a problem? You have a problem with me?
No.
Okay. Do you need to go now?
No. She needs to.
Then you'll go. Okay. Yeah, if you feel sick, of course, you should go home if you feel sick. But you want to finish your physics. Very good. What do you have after lunch? Interesting. Okay, we have this?
Yeah.
Potential difference. Come on, focus. Potential difference, or PD for short, is basically just another name for voltage. But they like using this one in the exam. So please make note of this. Potential difference is another name for voltage. Yeah? Continue? Now, the next thing is called EMF, electromotive force. Now let's try and break the word down. This electro, what does electro mean? Electricity. Motive? Motion, and force is force. So electromotive force is the force that makes the electricity move. The way to think about it. Basically, in simple terms, the electromotive force is actually just the voltage of the battery or the cell. That's all it really is. So electromotive force is just the battery voltage. So for example, if you look at a battery, hang on, I can get this. This one here says 3.7 volts on my battery. Do you see that? Well, you can't see it, but if you check your battery, it will say it as well. This is called the EMF, is 3.7. On your battery, that is called the EMF. You're checking yours? Yeah.
Okay, so what's the difference between PD and EMF then?
It's just in terms of where it is in the circuit, really. So when it's on the battery, we actually call it the EMF, even though it's still, you can see it's still a voltage. The difference is just when the resistor uses up voltage, so we could call it a voltage, but things that provide a voltage, we actually call that an EMF. But essentially it's measured in volts as well. What's it on your phone from? Don't know, it's a mystery. 4.35. Because your phone is bigger. Continue?
Yeah.
It's generally defined as the electrical potential for a circuit. A device that supplies electrical energy is called electromotive force, or EMF. Guys, wait, there's a lot here, please, your full attention, please, Mahmoud. So firstly, EMF is just the voltage of the battery. Yes? Next sentence. It's generally electric potential for a circuit. In other words, things that provide the energy we call in the circuit the EMFs. Or really, we should call it electromotive force, or EMF. We call it the seat. So, another name for EMF, the battery, is called a seat. Just like this. I know it's strange. Yeah. EMF change a chemical energy into electrical. This is known as an EMF as well. So, in the battery, it's chemical, and it's turning its chemical process into electricity. So this is a typical EMF process device. There is a lot here. For the exam, let's see what you need. Basically, for the exam, for the definition, it's enough to have the first sentence, I think, will do the job. Yeah. There's a lot here. I would like you to write it down, but if you want to just make your notes shorter, that's fine. You don't need to write every single word here, because I need to move on, and there's too much for the exam. So what is the difference between EMF and PD? Iyad, you were asking me this, what exactly is the difference then? Well, for example, an EMF of 1 volt means each coulomb of charge gives 1 joule of energy, whereas a voltage of 1 volt means each coulomb could do 1 joule of work. So in other words, the difference is an EMF of 1 volt means it can give you 1 joule per coulomb, whereas a voltage of 1 volt means 1 joule per coulomb of work was done. So in other words, EMF gives and PD takes. That's really the difference. Yeah.
So like EMF is in the battery and PD is in the resistor.
Essentially, that is the difference, yes. Of course, there's lots of technical language here and ideas, but at the end of the day, it comes simply down to that. Now, your physics lecturer at university might say, oh, no, there's more to it than that, but really, at the end of the day, it's enough for us to know that. There's a lot here. You don't need to write everything down. Try to make some summarized notes. Good question. How? I don't know. Fuang, even if you just got the first sentence, that's okay. Okay. I need to push on, but you can watch the video if you want to add to your notes. So basically, EMF gives and PD takes. Right, now let's have a look at the circuit below. I want to explain this circuit. It's an important circuit. When you have a battery, you might say, oh, this isn't a battery, this is a cell because there's only one. But in real life, what you can't see is the inside. Inside of this battery, there's actually many cells.
You mean that inside the battery?
Inside the battery, there are many cells.
How many?
Oh, it depends on how good your battery is. So a good battery would have many cells in it. An old, cheap battery would have maybe just 2 cells in it.
And do all of
In
them
fact, actually, now that you talk about it, the battery in your laptop, when you look it up online, it tells you how many cells it is. So, for example, this battery is quite small, and I remember when I bought it, it said a 6-cell battery. If I got a 12-cell battery, it would last twice as long. So actually, when you buy batteries for laptops online, they actually say how many cells they are. So a 6-cell battery will be twice as long of charge as a 3-cell.
Okay.
Yeah.
So it means the more.
More cells means last longer. Yeah. You got it? Yeah.
All the cells that provide the same between lots of.
Yeah, what they do is basically they squeeze more cells into the battery. Now that's more expensive because you have to shrink it down, but you're right, more cells means more charge. Yeah? Now, what you can't see also is not only are there cells inside here, but there's also a small resistor. This resistor is what makes the battery get hot. So when the battery gets hot, it's because of the resistor inside it. The phone, the laptop, whatever. And we cannot avoid this. Whenever we make a battery, no matter how hard we try, it's like there's a small resistor inside of it. This is what gets hot. So can you see in my picture here, this is like a battery, and inside the battery there is a cell and a small resistor. Now please, it's not like there really is a small resistor inside it, because if there was, you should just take it out, because you don't want it there. Do you understand? I'm saying there's like a resistor inside of it. Do you understand? Yeah. So, what we have in this circuit is a small resistor and a battery, but we know it's not really there, it's just like it's there. And what we want to do is work out how big this resistor is. We cannot take it out and we cannot measure it, so we need to do it another way. Can you draw this diagram and I'll explain how it works? Do you remember what this is?
Variable.
Variable resistor, yeah. So by the way guys, this is exactly how you would go about measuring the resistor in your battery, by doing this process. And do you notice that in the battery I now call it EMF and not voltage? Yeah. Continue? Now, look, let's call the resistor here OR. We can change it, true? This is a variable one. Yeah? Let's use our good friend Kirchhoff. Let's use Kirchhoff's loop rule. So let's do this together. I'll start here, and the EMF, we'll just call it E. So we have E. What's next? Minus minus I or, yes? Next? I small or. So we got this formula. Can you write this down so far? Continue?
Yes.
There's another formula we can make from this, which will be kind of useful later. So we can say the EMF is equal to V plus I or, but then you might say, well, what's the V here? That's the same as I or. Now that's actually not as obvious as it seems, because you might, somebody tell me actually, this is interesting, why am I saying V is I big or and not I small or, because the voltmeter is around this.
Maybe because there isn't actually a resistor inside the EMF.
Not that. Good try though. It's worse than that. No. The reason is, it looks like the voltmeter is around the battery, doesn't it?
Yeah.
But believe it or not, it's around this resistor. And you might say, no, Stephen, you're crazy. Look, it's right around the battery. How do you mean it's around this? Now, look at what's happening with the current. The current starts here, and it goes left, 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 left. This is the start. Left, left, down, down, right, right, up, up, and this is the end. So this resistor is between the start here and the end here. In other words, imagine, if I move this from here to here, does it change anything on the voltmeter? No, because is there any resistor here? No. If I move it to here, here, here. Okay, so now it's here. Here. No, I just move it to here.
Oh,
the other one on the
Yeah, move it here. Now it's around this. Yeah, so I know it looks like it's around the battery, but believe it or not, it's actually around the resistor here. And that's why I can change it like this. And what's in common? The I. So now I can have this formula. This is in the formula book. But I don't find this formula helpful. No, I don't find this formula helpful because the problem is we cannot use this until we know the small or. Do we know the big or? Yeah, because if we're changing this, we can know it. And can we know the I? Yeah, we can know the I because we can measure it here. But we still don't know what the small or is. So I'm just doing this proof because this is in the formula book, but in real life this is not really useful. What is more useful is this formula, which I'll show you how it's useful. What was it? EMF equals, what was it? Oh, sorry, no, EMF minus V minus I small or equals 0. Now, if you look at your circuit, what are the things you can easily measure? The V and the I. So we can know the V and we can know the I. And what would we like to know about our battery? We would like to know our battery's EMF and we would like to know our battery's small or. Let me rearrange this a little bit. What I'll do is I'll take the V to the right here, and I'll get V equals minus I or plus EMF. Yes? And I'll get V equals minus or times I plus EMF. Now, which are the two things I know the values of? V and I. So when I change the resistor, what happens? The V and I's change. So I can have many values for V and I, so I should make a graph. If I put I here and V here, this V is like Y. And what's my I like? X. So what is this like? And this is like C. So what will happen is I can get many points for V and I can make a graph. And what does this point on the graph represent? The EMF. And what does the slope represent? Minus or. So by using this graph and this equation, I can find the EMF of the battery and the internal resistance of the battery. And this is how it's done in real life. So when you look at your battery and it has the EMF on it, and it has the internal resistance on it, it was some process like this to calculate it. This is important for the exam. And what's also important is that this is not in the formula book. So you need to basically use Kirchhoff's loop rule to make this equation and make this graph. In the exam, it will say, draw a graph, but it won't tell you what graph to make, and it won't tell you how to use your graph to find the OR and the EMF. So this is important. NB means important. You know this in English? NB means important. Oh, okay, forget it. No. Important. Right, write this down carefully, please. And again, we see we're using our buddy Kirchhoff. Got it? Yeah? Continue?
Yeah.
Right. Oh, I went through the whole explanation here. That's okay. Yeah, so really, I just want to do one example where I make the graph, and then there's one for you to try at home. So, here is the voltage, here is the current. What should I put on the X for this problem? The I, and here, the V. So, can you just write this table down, and then we'll make the graph for it. Yeah? Okay, so what do we have on the X? The I. So I'll type the I in first, and it's in amps. What's the first I value? 1. The next?
1.1,
Hang on, the I's. Yeah, it's decreasing by 0.1, is it?
Yeah.
Okay. And then, how far? Thank you. And then the voltage, or sorry, wrong word. What are we calling it now? Potential difference. What does it start with?
1.
1, then 1.2, then
1.2?
Increases by 0.1.
0.1 or 0.2?
0.1. 1.1.
Okay. Until the end as well.
Yeah.
Right, let's make the graph here. Insert chart scatter. Right. Where this is a graph to find EMF and or. Yeah. So on the x-axis is I in amps, and then potential difference in volts. And let me just draw in the line. Insert trend line. But I won't put in the equation. I want us to judge for ourselves. So if you were to continue this backwards, what would you say the EMF looks like it is? Yeah, 2 point. Yeah, something like this. About 2 point.
It's not 2.3. It should be less than 1.8, between 1.8 and 2.
Yeah, it's not. I need to continue it on. Let's just do our best. Shall we say
2.2.
2.1? Now let's just write this down. Okay, 2.2. Write down 2.2 then.
Why is 2.2?
No, I'm just judging with my eyes. I'm not being exact. If I had graph paper, I could do it better. What do you think it is?
1.9.
1.9? No. This is the y-axis. It needs to continue it here. This is the y-axis here.
To touch the line.
Yeah, it has to touch the line. Right, can you write that down? So we think the EMF is 2.2. Now,
How did you know it?
I want to have my lunch. You need to draw. I can't draw here. You need to draw this back to here. I'm just going to allow this to speed it along.
This time, huh?
Yeah. Next time it'll be a problem. Okay, now, the internal resistance is what? Minus the slope. So, what would we say the Y value is? 1.9 minus, let's type it in. Actually, you type it in and tell me what you get. We'll see if it matches what I get. Try. See what you can get. What did you get for or? Yeah.
Can I go now?
Yeah, I'm just about finished, but if you need to go now, you can.
Minus 1.13.
1.13, yeah. Now remember, that's minus, so the or is 1.13.
Oh, okay.
For you, what did you get, Fuan?
I don't know.
You know how to get the slope? Go around this way. Yes, you can get by? Yeah, what did you get? Wait, what did you get for slope? You're putting in values, y2 minus y1 over x2 minus x1.
So it's 2.2 minus 1?
No, I would say 1.9 minus 1 over 1 minus 0.1? Something like this?
Yeah.
I got about 1, roughly. Now, yeah, 1. Let's see what Excel tells us. Excel will give us the exact answer. Two was the EMF. So I guess this goes to 2, not 2.1 or 2.2. And the small or is exactly minus 1. This is a 1 here.
Oh, it's minus x, so the minus is that.
Minus 1, yeah.
Yeah.
We should have no.
Minus 1 is
It
1.
goes to 2, because if you look at the other points, it's like the.
I suppose.
Yeah, in the middle, then touches.
It's in the middle.
Then touches middle, then.
Oh yeah. Sorry, you're right. Yeah. Touches middle. Yeah. So the next one is 2. Yeah. Yeah. Okay.
How do you get the minus 1?
There's minus 1 there.
Yeah, how do you get it?
The computer got it.
How?
It's a very smart computer. I don't know.
It's y1, y2,
Y2 minus y1 over.
2 minus 1.
So
Yeah.
the y is 2.
Y2 is
the y
2.
over. Like this.
Y2. Yeah, guys. If you want to do it, if y2 is 2,
Yeah.
so it'd be 2 minus 1.
Yeah.
Yeah. Over 1 minus 0.
Yeah.
Yeah.
Yeah, that's what I do.
Yeah, good for you. You got it right. Good job.
Minus 0? It's
Oh.
it's come plus 1,
Here.
not minus 1.
Yeah, but for or.
The line.
It's plus 1, yeah.
Oh.
Here,
No, but that's the slope. The slope is minus 1. Remember, this.
But it's minus 1 because it's
yeah,
minus
it's minus the slope.
minus the slope.
The slope, yeah, the slope is minus 1, so the or is minus 1.
Yeah.
Yeah. Wait, I want to put the questions up. So, this is your homework for Friday?
No.
Yes. Look, you only have this for Friday. And then I'll do the next lesson.
1 hour is like we can do like homework and lessons and then.
Homework lesson and maybe even the answer to the next homework.
Yeah, and then.
If I give you time to work on it. 1 hour max I think is fine, and then the remainder will be working on the essay. So if you want to bring your laptop for Friday, that'd be a good idea.
We are also having ICT, so we will have to
Bring it anyway.
Yes. Can I close this?